Hello everybody, thank you for watching Crystalline Science. This is Crystalline Mahalik here teaching you mid-level science. Today we're going to talk a little bit about thermal energy. And so thermal energy is what creates heat. And thermal energy is a type of kinetic energy. And if you don't remember what kinetic is, it means movement. And so when you think about little particles, like atoms or molecules, picture the molecules that make up water. And I put, a pot of water on the stove. And since water is a liquid, those molecules of water are slowly just sliding past each other. Now, when I start to heat up the water, the heat transfers to those particles and gives them more energy and makes them move faster. And so much like the friction of your hands rubbing together and heating up, those particles are moving and bumping into each other and it makes them move faster. And so they start to heat up also. And so in that pot of water, those fast-moving particles on the bottom of the water will bump into the slower-moving particles above them until eventually they're all bumping into each other. And some of those particles will gain enough energy to become steam. And so that's kind of just how thermal energy works. And it's also important to point out that there is no such thing as cold. Like no such thing as cold energy. It's just the lack of thermal energy. So if your house is cold, you shouldn't say, man, it's cold in here. You should say, wow, there's a lack of thermal energy in here. The thermal energy is missing. It's not hot in here. Anyways, just to kind of prove that point, if you think about packing a cooler for a 4th of July picnic and you put, hot dogs and watermelon that were in the fridge into a cooler of ice, the hot dog and watermelons are about 40 degrees Fahrenheit if they came from the fridge. And when you put them into the cooler with ice, ice has to be less than 32 degrees Fahrenheit to be heat or to be ice. What did I just say? Anyways, when I put the hot dogs into the ice, the heat from the hot dogs, since they are warmer than ice, are absorbed by the ice, which melts the ice, right? That's why our ice melts. And so the ice isn't making the watermelon and hot dogs cold. The hot dog and watermelons are heating up the ice. And so as the ice is absorbing that energy and taking it away, the ice melts. And so heat flows 3 distinct ways. We have radiation, conduction, and convection. Now, radiation is heat that you can feel, heat from a light bulb, or if you put your hands near a fire, a flame, and you can feel that direct heat, or if you're outside and you look up and you can feel the sun on your face, you feel that warmth, that is that direct radiation. You can also feel the heat register or a radiator or a heat vent in your house. If you put your hands over it, you might feel heat coming off of it. That's another example of radiation. Conduction is a little bit different, usually traveling through things like metal. So if you put a metal pan on the stove, the metal pan is going to conduct all the way up the handle, or if you have a metal spoon in that pot, that conduction goes through the particles of the metal, and it might burn your hand if you touch that metal part without a oven mitt or something like that, which is also why a lot of pots have a plastic or rubber handhold on it. That's just in case, just in case you forget to use a pot holder and so you don't burn your hand. That's Thor, by the way. Hi, Thor. Hi. Okay. Anyways, so the last part is convection. So convection is when heat rises. We all know that heat rises. It's just something that happens, much like in that boiling pot of water I talked about earlier. The heat came up, and as the heat rises, it displaces the cooler particles and sends them to the bottom of that pot of water. And so you get like this cyclic motion throughout this pot of water, which is also why your furnace is in the basement. If you need to take a moment to pause this video and go look in your basement, make sure your furnace is there, you can right now. Go. Anyways, the furnace is in the basement because heat rises, so it only makes sense that we would put the furnace in the basement so that heat could rise through your home and we could have convection currents to warm your whole house. You might not feel the direct heat, but if the heater's over there and I'm over here, my house becomes almost one stable temperature because of all those convection currents going around in your home. This is also a good point to note that it happens on the beach. Those nice sea breezes that happen when you're at the beach happen because the sun beats down on the sand, which makes it really hot. Those particles rise, they go over the ocean, they get cooled, they fall, and they create this big cycle that creates all these, sea breezes. So it's really windy at the beach when we go there. So today, I'm challenging you to think about all those things that you just learned and consider conductors and insulators. Now, I talked about metal being a conductor already, but you also might not know that tile floor is a really great conductor of heat, which is why when you walk on tile floor barefoot, your feet get cold or not hot very quickly, because that tile floor is such a good conductor of heat. It will absorb all that thermal energy and it'll just steal it from your feet, leaving your feet very not hot. All right, so today I want you to see if you can find these things in your home. You're looking for some sort of a some sort of a paper box, this thin paper board. Look for one of those. Look for some styrofoam. Any kind of styrofoam will do. I would recommend like an egg carton or something like that. Cut one of these out. You just need a small piece of styrofoam, or if you can use a piece of a styrofoam cup or something like that. Try not to go out and buy any styrofoam. It's really bad for the planet, but use some that's around. If you have some packaging peanuts, use a couple of those. Also, grab a plastic bag. You can reuse a plastic bag from, say, tortilla shells or something like that, or you can find one like this. You should be able to reuse it later. Also, find a piece of foil. I just kind of took a piece like this, cut it in half. You just need that little piece there. And then a piece of paper. So with all these things, the paper box, the foil, the bag, and the piece of styrofoam, what I'm challenging you to do is use that equipment to build a cooler to try and keep an ice cube alive for over 2 hours. And so think about, is this a conductor or insulator? Is this a conductor or an insulator? Think about some of the purposes that these things are used for. Is this a conductor or insulator? I would also like to point out that in your house, there is air. If you have double paned windows in your house, there is air in the middle of those windows. So if you want to use this bag as just, a home for air, you can, put some air into it and seal it up like a balloon and use air as part of your cooler. And you can put everything inside, inside the box with the foil. Think about where you're putting things and how you are layering up. Once you put your ice cube where it needs to go, make sure everything gets into the box wherever you want it to be, and then let it set for 2 hours and check after 2 hours and see if your ice cube has survived. If it did not survive, try and rethink how could you do this differently and keep rebuilding until you're able to do that. I would recommend you put this on a plate also, because usually I do this with one of those little milk cartons from school that has the wax coating on it so it doesn't melt all over the place. But since this doesn't have a wax coating, you can just put it on a plate so that you don't get water all over your mom's coffee table or something like that. But good luck. Let me know how you do and have a good one. See you later. Miss you. Bye.